Okay, today we're going to be starting with 3.5, which is equations of inequalities, or equations to inequalities. So we've been talking a lot about solving for that variable. Today we're going to be finding similar ideas with solving with the variables, but we're using different symbols. So today, we know that an inequality is a mathematical sentence that uses less than or equal to, greater than or equal to, or not equal to compare two quantities. So here, a couple different examples. We have 3 is less than 16. We have 12 is less than or equal to 12 because it is equal. We have 15 is greater than 10. 13 is greater than or equal to 7. And 9 is not equal to 3. We can also use the same thing, boys and girls, just with the variables. We can say B is less than 6. 12 is less than or equal to M. 15 is greater than T. A is greater than or equal to 7. And X is not equal to 3. You might be saying, but what are all these variables? Well, we're going to talk a little bit about how we can plug different numbers in for these variables to see if it's true or false. If I plug 5 in for B, is 5 less than 6? It sure is. So we're going to talk about how we can plug different numbers in to see if it makes the statement true. Okay, here's some English examples. Children under 6 ride free. Children ride free through age 6 because that equal to sign. You must be older than 12 to drive a go-kart. You must be at least 12 to drive a go-kart. 4 apples are not equal to 3 mice.
You ride your scooter 2 miles. You must be at least 48 inches tall to ride the bumper cars. You have less than 3 days to write a book report. Your movie ticket costs $10. You have less than $10 to spend on snacks at the movie. Decide whether each situation could be represented with an equation or an inequality.
So for these, a very important thing that you need to do is underline your key words. Here I see at least. Here I see less than. Here I see costs. And here I see less than again. What about this? You ride your scooter 2 miles. Okay, so I know here, do you ride more than 2 miles? No. Do you ride less than 2 miles? No, you ride 2 miles exactly. So an equation, you're going to remember, has that equal sign, where an inequality doesn't have an equal sign, but it has the greater than, the less than or equal to, or the greater than and equal to sign. Okay, so if you ride your scooter 2 miles, we're not going greater than 2 miles, we're not going less than 2 miles, so it's an equal sign, it's an equation. Here, at least means that we're going to be using one of these signs. Greater than, less than, you must be at least 48 inches tall to ride the bumper cars. So you can't be 49 inches tall, you can't be 50, you have to be less than 48 inches tall. Here, we have another less than sign. Here we have your movie ticket costs $10. Does it cost $9? No. Does it cost $11? No, it's $10 on the dot, which means it can be represented with an equal sign. You have less than. Well, less than means that we have a symbol like this, so that is an inequality. Go ahead and copy those down.
Which situation or situations could be modeled by inequalities? You must be 13 or older to buy a certain DVD. You should not drive over the speed limit of 70 miles per hour.
Okay, so here a keyword is or older. Okay, could you be 14? Yes. Could you be 15? Yes. So one should be a solution. So both can be represented with that inequality because you could technically, in the previous example, go 68 miles an hour, you could go 5 miles an hour, you just can't go over that 70 miles an hour.
Wow, I never realized how many inequalities are in my day. Starting work at 9 o'clock means I could arrive at 9 on the dot, or I could arrive at 8:59 or 8:58 or 8:57. Or having a lunch hour that starts at 12 o'clock means I'm at lunch from 12 o'clock to 1 o'clock, and all those minutes in between. When you write an inequality, you need to think about whether you have a starting value, an ending value, or both.
Inequalities can describe height requirements, speed limits, time limits, and many other situations. Click and drag an inequality to the picture it describes.
So for here, if you're driving a truck that is higher than 14 feet, do you think that you're going to be able to get under that bridge? No. So if you're a truck, okay, or any variable, you want to be less than 14 feet tall. So which one can be represented with that? Well, I know that there is x is less than 14. This one's difficult. Okay, you can park here, but you have to park after 8 a.m. Okay, so x has to be after or greater than 8 a.m. But x also has to be less than 6 p.m. Okay, so could we park before 6 a.m.? No. So let's look at these. Which one is it going to be? Well, here it says x, since we flipped it, has to be greater than or equal to 8. And why would they use this 18? They're using this 18 because of military time. So if noon is 12, okay, and then if 1 p.m. is 13, 2 p.m., 14, 6 p.m. would be 18. So this would be our answer. Okay, what about this next one? It says Dinosaur City limit. Elevation is 5,900 feet. Okay, so that means that your elevation is x has to be less than or equal to 5,900 feet because it's not taller than that, it's less than that. Go ahead and copy those down. The height of the bridge is 14 feet, so the vehicle must be less than 14 feet tall to pass under it safely. The range for 1 hour parking is from 800 to 1,800 hours, and the highest point of the town of Dinosaur is at 5,942 feet above sea level.
What inequality models the situation?
Okay, so this says 35 miles an hour. Should you drive 36 miles an hour on this? No. 37? No. Would 34 be okay? Yeah. Would 35 be okay? Yes. So a key thing for you to know is that it's included. 35 is included. So you'll have that line underneath showing that you can also count 35, which means A is not an answer and C is not an answer because they don't include 35. So which one says less than or greater to 35? Which symbol do you think it is? The correct answer should be M is less than or equal to 35 because it means the speed should be less than or equal to 35 miles per hour.